Got the mass of 1 mole being equal to the mass on the periodic table in grams. So gases can be, elements can be gases, liquids, or solids. And the gases on the periodic table are written in red, the liquids are written in blue, and the solids are written in black. So if you look on the periodic table, you'll see that the majority of the elements on the periodic table are black, so they are solids at room temperature. 2 of them, bromine and mercury, are blue, and so they're liquids. And then over all the way on the right, those are red, so they're gases. The clear ones are radioactive, and so they are right. So they're radioactive. Okay. 91 naturally occurring elements. The others are either made in the lab or they exist because they are radioactive decay trash. So, for example, that's a weird thing to say. For example, plutonium number 94 is the radioactive decay product of uranium number 92. So when number 92 decays, it becomes plutonium 94, right? So that is how it exists. All right? Hydrogen makes up over 75% of the 75% of the universe. And that's because hydrogen is number 1. It's a proton and an electron. So it is the first element to exist, and then all the other elements sort of like happen because in a nova, in the very first starting of a star, there's enough energy for hydrogen to fuse with another hydrogen and make helium. And then that goes on, right? And so as a star is being formed, there's fusion that's occurring, but out there in space, there's an overwhelming amount of hydrogen that's helping to build. So that's why it's 75% of the universe, because only planets and only atmospheres have a lot of other elements besides hydrogen. Nitrogen makes up 70% of our air. Only 12% of what you breathe in is oxygen. So our body is extremely good at, extremely effective at extracting what we need from the air. Carbon, hydrogen, and oxygen are 90% of the human body. And so then students say, well, that doesn't make any sense because we're 75% water. Well, we are. And water is hydrogen and oxygen. So that's included in there. We are, by nature, carbon-based organisms. And what that means is, our base chains, and the majority, as in like 99% of what we exist on and the molecules in our bodies are based on carbon chains. And that's because carbon has the element of carbon, number 6, has this unique ability to form these very, very long chains, which allows carbon to be this foundational chain for millions and millions of compounds. And it takes many, many compounds, millions of compounds, to create an organism as complex as we are. Over 10 million known compounds. So they can even, now, that's what that virus, what the vaccine was for the virus, they make them in the lab. They literally say, we need a compound that's going to do this. They go into the lab, they work on it, and they create it. They build it. They build whatever compound they need now. Organic compounds have carbon in them. And this is what I was saying up here. We are carbon-based organisms. We are organic organisms. Any compound that has carbon in it is called an organic compound. That is what organic chemistry is. It's the chemistry of compounds that have carbon in them. All right, now the mass of 1 mole of a compound equals the atomic masses added up. Okay? So let's do an example. And let's use water as our example. Yeah, 1 mole. And let's use water as our example. So water has 2 hydrogens and 1 oxygen. So I'm going to say 2 times, and then I'm going to look up hydrogen's atomic mass, which is 1.01. And then I'm going to multiply them together, and I'm going to get 2.02. Then I look up the atomic mass of oxygen, which is 16.00. I multiply them together, and I get 16.00, and then I add them together. So what I get is 1 mole of H2O is equal to 18.02 grams of H2O. So we added all of the masses together, and we got in grams what the mass of water is. Okay, really simple. You just look it up and you add them together. All right, we're going to work a lot on that. So that's like an exposure thing, right? But what you want to know is that the mass of the compound is all of the masses of the atoms added up. All right? Now, the law of definite proportion, so you are definitely going to want this page for your homework, okay? The law of definite proportions says a compound is always composed of the same elements in the same proportion by mass. So that sounds really complicated. But what it means is if I have water, whether I have 1 molecule or 1 gallon or an entire lake full, I can tell you that if I take the mass of hydrogen over the total mass of the compound, which is 18.02, as I just found out, times 100, I get 11.2% hydrogen. So no matter how much I have, it does not matter whether I have a lake full or 1 molecule, I will always have 11.2% hydrogen and 88.8% oxygen by weight. It doesn't matter how much I have of water. It doesn't matter how much water I have. My sample will always contain 11.2% hydrogen and 88% oxygen, because every molecule of water in that sample will be H2O. That's what the law of definite proportion states. All right? Now, since I know that, I now can use that to figure out a lot of things. So let's see how this works. First of all, ibuprofen, here's an example problem, is C13H18O2. It is 75.69% carbon, 8.8% hydrogen, and 15.51% oxygen. How many milligrams of carbon are in 200 milligram tablet of ibuprofen? So we have this technique in chemistry, okay? It's just a trick. It's something that we do. We use it all the time. So you're going to use it all the time. Anytime there's a percentage, we do the following. We assume 100 grams, or whatever it is. We assume 100. So for example, let's say that I have 243 students and 48% of them are girls. And I say, how many students are girls? Well, the first thing we do is I say, assume you have 100 students. How many students are girls? 48. There you go. So now what I've done is we've set up a conversion. 100 students, 48 girls. If I have 100 students, I have 48 girls. There's a conversion there, isn't there? Right? Because I just set up a conversion. 100 students, 48 girls. So when you assume 100, you lose your percent. When you assume 100, you convert your percent into whatever unit you're using. And now I can say 243 students. For every 100 students I have 43 girls, cancel out students, and I'm done. Now I can use my boxes, right? So that's what I'm going to do. I'm going to assume 100 milligrams. That's what I'm going to do. I'm going to assume I have a 100 milligram tablet, right? So if I have a 100 milligram tablet, because you see, how many milligrams of carbon are in a 200 milligram tablet? Well, let's say I have a 100 milligram tablet. If I have a 100 milligram tablet, how many milligrams of carbon do I have? It is 75.69% carbon. So if I have a 100 milligram tablet, I have 75.69 milligrams of carbon, don't I? You see that? See that? Because when you assume 100 of anything, you eliminate your percent. And now I've set up a conversion that I can use. I can use it anywhere I want in that box, that long string of boxes. All right? So now I'm going to start with 200 milligram tablet. Okay? What unit goes down? Yes, milligram tablet. That's right. Milligram tablet. How many milligram tablet? 100. For every 100 milligram tablet, oh, look, I can cancel out milligram tablet. And then where do I go from here? 75.69 milligram of carbon. And that's where I am. Look at that. I got rid of my percent. See that? I got rid of my percent. And I'm able to calculate what I need. And the reason, I want to be clear, the reason I can do this is because no matter how large that sample of ibuprofen is, it's always 75.69% carbon. So this could be like 8 kilograms of ibuprofen. Convert to milligrams, and now I can use for every 100 milligrams, 75.69 milligrams is carbon. Now I run my math, 151.4, 4 digits, 4 here, 4 here. I don't worry about the 100 milligrams of carbon. Okay? Let's do another one. You ready? Silver iodide powder has been used as an antiseptic and as an agent to seed clouds for rain. Silver iodide is 45.9% silver by mass. If you separate a 50-gram sample of silver iodide into its element, how much silver would you have? So, assume 100%. For every 100 grams of silver iodide, they even gave us the formula, right, AGI. How many grams of silver do I have? $45.9. So now I'm ready to go. How big is the sample I'm breaking down? 50 with a decimal point. Notice the decimal point, that's important. Of silver iodide. What unit goes down? grams of silver iodide. How many grams? 100 grams. And what goes up top? For every 100 grams of silver iodide, I have 45.9 grams of silver. I cancel my grams of silver iodide, and I'm left with grams of silver. Yeah? Is this starting to make a little sense? Yeah? Okay. But you are going to want these problems with you to do the homework, I'm telling you. Okay? Because you'll say, like, remember, this is like stage 2. You're watching me do it, but when you do it at home, having this with you. Stage 3? All right, good. Okay, so when I multiply this out, I actually get 23 grams, see the 2 digits with the 50, of silver. Okay? All right, the last problem is a little different. Okay, compound 1 contains, we're going to test 2 compounds, unknown compounds. Compound 1 contains 50 grams of hydrogen and 120 grams of oxygen. And compound 2 contains 2 grams of hydrogen and 32 grams of oxygen. Are they the same? So here's the thing. If they are the same, the percent would be the same. Okay, now this is what the law of definite proportion says. No matter how big the sample, whether it's 100 grams or 250 grams, the percents of each element would be the same. So now you go back and you look and see what I did here. I took the hydrogen over the total. This is in your notes, by the way. Percent composition is in your notes. So you're going to look for that in your notes, right? Go to the back through the pages, and you're going to see we did percent composition, right? And you take the percent of the element in the compound over the total mass of the compound times 100 gives you the percent of the element in the compound. If an element has 11.2% hydrogen and 88.2% oxygen, it is water. There is nothing else it can be. Are they the same compound? They are indeed. But if it is 27% hydrogen and 73% oxygen, it is not water. That is what the law of definite proportions says, okay? So when you are trying to identify if compound 1 and compound 2 are the same, or if sample 1 and sample 2 are the same, you are looking at the percentages that you are holding in your hands here, right? The percentages that you are calculating. Are they the same? Does this make sense? Okay? All right, so 5 problems tonight, plus your vocab quiz, which is matching to those right, definitions, yes? Okay, all right. Tomorrow we have a lot of little things that we're going to do, okay? All right.